Okay, today we learned all about classifying angles and triangles, so we're going to learn a lot of vocabulary. We'll learn to classify angles as acute, obtuse, right, or straight, and then we'll classify triangles by its sides and by its angles. So acute, this is an angle whose measure is less than 90 degrees. So we would say this is an acute angle. It looks like it's about 45 degrees. So it's less than 90. Obtuse is an angle whose measure is greater than 90, so bigger than 90. This looks like it's about 120, and that would be greater than 90. A right angle is an angle whose measure is exactly 90 degrees, so we show a right angle by putting the square there. Doesn't look like much of a square. There we go. And that will indicate that this is 90 degrees. A straight angle is an angle whose measure is 180, so a straight angle here would say that this measures 180 degrees. Example 1 says to classify each angle as acute, obtuse, right, or straight. So we look at AOB. It says that it is 30 degrees. So it's 30 degrees, so we know because it's less than 90 that it is acute. Okay, the next one is COF. We can see here that it passes 90, and if you're not sure, you could add all these values up. 25 and 65 add to give you 90 plus 20 is more than 90. It's 110. And we would say this is obtuse. Our next one, FOA. So it's straight line there, and because it's a straight line, we know that it's 180 degrees, so we call it a straight angle. EOB. We're going to add all these up. We can see that 40 plus 20 is 60, plus another 65 is 125, and that is bigger than 90, and so we call it obtuse. Our next one is COE. We want to add those two. 65 plus 20 is 85. It's less than 90, so we call it acute. And then our last one, AOD. If we add 30 plus 40 is 70, plus 20 is 90. So we have a right angle. Scalene, this is when all sides and angles are different on a triangle. So we have all sides and angles are different. All these sides have to be different lengths. And when they are, that will make angle A, B, and C different. An obtuse scalene is when one angle is more than 90 degrees. So here you can see angle A is much greater than 90 degrees, so this is what's known as an obtuse scalene because your other two angles are different sizes as well as all three sides are different lengths. Acute scalene is when all angles are less than 90 and all of your sides are different lengths. So we can see A, B, and C are all less than 90 and all the sides are different. And then a right scalene is when you have one of the angles is 90 degrees and the other two angles are different measures. Or you could say all the side lengths are different. Isosceles is when two sides and angles are congruent. So if I have this isosceles, I show that these two are congruent by doing the hash marks. If those are congruent, then it also makes angles A and B congruent. Obtuse isosceles you can see that these two sides are the same, which would make the angles here A and B the same. We have an acute isosceles. That's kind of like what the first one I drew. All of the angles are less than 90, and we have two sides that are still the same. Here, A and B are also the same angles. And then a right isosceles. These are the same as well as A and B, and what's unique about this is if A and B are the same in a right isosceles, then A and B are both 45 degrees. Equilateral triangles, these are, if it's equilateral, that means all sides are the same. So all sides are the same. What is also unique about this is that it's also equiangular. So if all sides are the same, then all the angles are the same. And if all the angles are the same, then each of those angles have to be 180 divided by 3 angles is 60 degrees. So all 3 of those are the same. Why are there no obtuse equilateral triangles? An obtuse angle means that it has to be greater than 90 degrees. So if we have 3 angles that measure more than that, say 100, to be equilateral, all the angles will also be the same, and if we add all these, it is much greater than 180 degrees. Okay, so we can't have obtuse. Why are there no right equilateral triangles? Again, this would be, if it was equilateral, then all the angles would have to be 90 degrees, and if we add 90 degrees 3 times, it is much greater than 180 degrees. So because they add to be greater than 180, you cannot have a right equilateral triangle. Example 2 says to classify each triangle by its angles and by its side. So because there's that right angle there, we call it a right triangle. So we say it's right by classifying it by its angles and by its side. All these sides are different lengths. So we call that scaling. On B, all our angles are less than 90, so we call that acute. And all the sides have different lengths, so we call that scaling. On the last one, all the sides are marked that they are the same, so we call that equilateral. Because all the sides are the same, all the angles will also be the same, so we call that equiangular. And on our last one, we see that only 2 sides are congruent. We call that isosceles. And then all the angles are less than 90, so it is acute. Alright, hopefully that will help you with your 9-1 classifying angles and triangles.